Okay, I'm going to go over some of the questions that you guys have asked me over the last couple of weeks. And just so I can annotate this while we are going through it, here we go. Okay, first question, how to find triangles on in real life pictures. So one of the assignments we were doing, you uploaded a picture of something that had a right triangle in it, right? And you want to know, how do you actually find that right triangle, right? There's a few different ways you can do this. I always suggest using a ruler, compass, or protractor, obviously, but there are other ways. For example, most of the assignments we do are on Google Slides or Google Classroom, and you can actually click on Insert Shapes, and then click on the right triangle looking shape, right? And then line it up with your triangle, and that will give you the points of where your triangle is, okay? You'd also save a right triangle picture from like Google Images, and that would work fine too. Okay, next question. Can you add a and b to find the hypotenuse rather than a squared and b squared? Short answer is no. There is an example. Rainbow pen, yeah. There is an example right here. Actually, two examples right there. One example. I'm going to do the second example. I'll do one more example over here. Keep saying example. Okay, let's go over an example of this. I said it again. Okay, let's say we have a triangle, right triangle, and we're gonna call side A, side, ooh, A. I don't know why it's not letting me write A here. Redo. A equals 1, B equals 2. There we go. We are in business. Okay, so let's use Pythagorean theorem like normal. A squared plus B squared equals C squared. Okay, so I'm going to replace 1 for A and 2 for B, and then solve. Okay, 1 squared is just 1. 2 squared will give us 4 equals C squared. 1 plus 4 is 5. And if we want to get C by itself, do the opposite of squaring, so take the square root. So C equals the square root of 5, which is somewhere around 2.24, I believe. We can double check my answer here. Square root of 5. Yep. Yeah, about 2.24. Okay. Let's see though. What if we did just A plus B equals C? So in this case, we're not squaring the answer. We're not squaring A, we're not squaring B, we're not squaring C. So in this case, we would have 1 plus 2 equals C, which we know using the Pythagorean theorem, which we know is also accurate 100%. So instead of C here, I'm just going to cross that out and write 2.24. Now 1 plus 2 we know is 3, and 3 is not the same as 2.24. Therefore, no, you cannot use A and B to find the hypotenuse. You have to use Pythagorean theorem as is. So A squared plus B squared equals C squared. Okay, next question. Is the square root of A squared plus B squared the same as adding the square root of A squared plus the square root of B squared? Short answer, no. There is an example. If you click on the link right here, click on that link, it'll go over a couple examples of that. I didn't want to include those whole examples on this video, because then this video would be like 30 million minutes long, and nobody wants that. Okay, next question. What jobs require the Pythagorean theorem? So on one of our assignments the other week, you guys actually came up with different ideas on how we could use the Pythagorean theorem in real life. So I just went through and took a few of the examples that you guys gave. Obviously, this list is not totally inclusive. There are so many different ways, so many different jobs we can use Pythagorean theorem. or distance formula. Okay. But there's a list for you in case you need specific examples. This question also goes with that one. Can you give more examples of the distance formula and how it can be used? So really, distance formula or Pythagorean theorem can be used to find the distance between any two things. It doesn't matter what they are. If we have, let's say we have planet A here, and we have planet B here. Any two things can be connected using a right angle. Okay, and using those measurements, which are usually a lot easier to find than this one, you can find the length of that one. Okay, again, it can be any two things. Any two things. It could be 2 points on a graph, 2 dogs in a park, 2 houses. Maybe you're trying to find out which house is going to be closer to a special someone's house. I don't know. Awkward. Okay, next question. How did someone figure out Pythagorean theorem in the first place? That's a fantastic question. Okay, so way back when, there was this cool dude. His name was Pythagoras. Pythagoras. He had pretty freaking sweet beard, as you can see. I'm going to do my rendering of Pythagoras. He's got some cool shades on. Lovely, lovely Greek nose. Beard. And a cool wrap thing on his head. There's Pythagoras. Somebody should frame that. Okay. So way back when, this is like 500 BC, so a long time ago, there's this guy named Pythagoras. He was a Greek mathematician and philosopher, so he did a lot of thinking and researching. Now, Pythagorean theorem is named after him because he was the first one that we know of that explicitly demonstrated with geometry the Pythagorean theorem, okay, and proved it. There are some like tablets and artifacts throughout history that suggest there was knowledge of the theorem before it was called Pythagorean theorem, dating back to like 2700 BC. So really long time ago, right? This was like ancient Egypt, the Babylonians, right? But since Pythagoras is the first one that we have like substantial proof of him explicitly stating the Pythagorean theorem, it was named after him. No one really knows exactly what made Pythagoras think of it. We do know that he and his gang, or like he kind of had like a cult of mathematicians called the Pythagoreans. They did a lot of research in geometry, and some of that obviously was on how the lengths of sides of a triangle, specifically in this case a right triangle, are related. Okay, and that's how he found the Pythagorean theorem and proved it. Right? He proved that if you find the area of the square coming off side A, so the area of side A, which area of a square would just be that number squared, so A squared, and you added it to the area of the square coming off side B, so B squared, it would equal the area of the square coming off side C, right? So we have A squared plus B squared equals C squared. So he found out a way where if we know the side lengths of A and B on a right triangle, we can find side C. Okay. My voice just got really deep there. That was weird. Okay, just zenning out with Pythagoras here. All right. Next question. Does it matter which sides of the triangle are A and B? Short answer is no. Okay, so I'm going to draw you some lovely triangles here. Say we have this triangle. Here we have A, B, and C. And here we have B, A, and C. The important thing with Pythagorean theorem is that C will always be the hypotenuse. It has to be, or it will not work. Hypotenuse. Hypotenuse is basically that longest side of your triangle. It's the one that's opposite of the right angle. Okay, so C has to be the hypotenuse. A and B, though, you can switch those up and it won't make a difference. The reason that is true is due to the commutative property of addition. Right? This property says that we can add things in any order and still get the same answer. For example, 2 plus 3, I'm getting ahead of myself. 2 plus 3, we know is 5. Will give us the same answer if we did it the other direction, 3 plus 2. All right, so you can add in any order, and you will still get the same answer. That's supposed to be a plus sign. Oh, Lord. I'm really struggling here. Oh, it's because it's on the very side of my screen. Okay. So you can switch sides A and B up as much as you want over and over. Doesn't matter. As long as C is the hypotenuse, then you're good. Okay, next question. How do you do the Pythagorean theorem formula in reverse? So say, for example, we know B, and let's say we know C, but we want to find A, right? Or maybe we know A and we know C, but we don't know B, right? Essentially, you're using the same principles to solve for any variable. You're using inverse operations to isolate the variable of interest. So if you want to solve for A, you need to get A by itself. If you want to solve for B, you get B by itself. If you want to solve for C, you get C by itself, right? I went over specific examples in this video right here. If you click on that link. Again, I didn't want to include all those examples here on this video, or this video will be very long. So click on that link, it'll give you some examples. Last thing I want to go over is not a question. In the questions part of your Friday feedback, though, somebody said, I'm not saying who, but somebody said, I'm bad at math. And I just want to like shake your shoulders, kids, because no, none of you are bad at math. If you ever feel like you're way slower than other people, or you're just struggling a lot more, or you're frustrated, or getting problems wrong more than other people, it doesn't mean you're bad at math, okay? There's actually scientific research that shows that we don't learn as well unless we're struggling. Take me, for example. I'm terribly, terribly slow at math. I struggle with it on a daily basis, people. And I'm a math teacher, and I'm not bad at math. Everyone does it at their own pace, with their own strategies, their own struggles. What I struggle with might be really easy for some people, but what they struggle with might be easy for me, right? Everyone does it differently, but it does not mean you are bad at math. So no more saying that, okay? And if you still feel like you're bad at math, just, trust in Miss Monson. Lean on me. I got you back, okay? All right, I hope this video helped and answered some of your questions. Let me know if you have more questions, though.